Composite functions. Composite functions, we should be somewhat familiar with them. If you've ever encountered a situation in which the outcome of one thing actually depends upon the outcome of another thing, which depends upon an outcome of another thing. So for instance, perhaps you want to save money to go on vacation, and the amount of money you save to go on vacation actually is a function of how much you work at your part-time job. And the amount that you work at that part-time job is a function of how much school work you have. Well, this is a composite function. It's a function within a function. Composite functions are formed when the output of one function becomes the input of another function. So we're going to take a look at mapping of functions. We're going to have f of x is equal to x plus 2, and g of x is equal to x squared. So when I'm taking a look at g of f of x, and sometimes or often this is called g composed of x. Now maybe there's a little circle there. It's not an O, it is almost like a degree symbol suspended between the letters. But g composed of f of x is really the g of f of x. So how do we start? We start with the input of x, and we put the input of x, and it becomes, we apply the function f, and it becomes the output, f of x. Now we take the values of f of x, it undergoes g to become g, or to become the input of g of x. And what is the output? The output is known as the g of f of x. So just very quickly, I'm just going to maybe take, not those numbers. I'm going to take some unusual ones like -2, -1, 0, 1, 2. Always like to start off with those. If I have these inputs and I simply apply my set of instructions f to these inputs, what I get are these values. Now I'm not going to draw all the mapping arrows here, but okay, maybe I will. And then if I take these values of f of x, which are actually the outputs of my function, and I put these in my g function, well, the g function is defined, the f function was defined as x plus 2. The g function is just going to take my inputs and square them. And as I square each of these values, so this value here is the g of f of -2. On the other hand, f composed of g of x, in which we may write f composed of g of x, the input of x is put into my function g. So my input of x, g is applied to my input. Now I'm just going to maybe write those down. And if I apply my function g, look at my function g, well, what does it do? It just simply takes all my inputs and squares them. And then if I take these g of x's and I input them into my function f, apply my function f, they are just going to add 2 to my inputs. And there we have it. So we should note that the g of f of x does not equal to the f composed of g of x. We end up with the final result of being different. We could also write the g composed of f of x does not equal to the f composed of g of x. So, composition of functions. Let f and g be two arbitrary functions. And order does matter. The composition of functions, let's define a new function, h of x. And h of x is defined as f composed of g of x, and we would write that as the f of g of x. Now, something that something that I find helps me is if the g is closer in the x in the composition, well, the g will be on the inside, closer to the x in my nested functions. So if you program, you've probably heard that word nested before. So that's what we have, nested or a composition of functions. All right, time for some nonsense. I actually don't even know if I truly understand this definition if I pick it apart. F composed of g of x exists for only those x in the domain of g for which g is in the domain of f. Fair enough. Composite functions are functions that are formed when the input x is entered into one function, say for example f. And then the output, f of x, becomes the input to another function, g of x. And what we have just described was we start off with x, and then x is inputted into my function f, and then we have f of x. And lastly, this thing goes into my function g. So these words here are describing g composed of f of x. G composed of f of x.